Hi there. So today we're going to be going over the very first thing that comes up actually in AS level physics for CCEA, which is SI base units. So SI base units, to describe them briefly, what they actually are is basically they've been decided as the very basic units that every other unit can be derived from. So you'll often see meters and stuff like that. I'll not go over all of them now because we're about to go through them. But you can basically comprise every other unit out of these base units. So there's 7 in total, but there's only 6 that you need to know for your exam. So if we go over them, first of all, we've got mass, and that's measured in kilograms. We've got distance, which is measured in meters. We've got current, which is measured in amps. We've got time, which is measured in seconds. We've got temperature, which is measured in Kelvin. And we've got amount of substance, which is measured in moles. So those are the 6 that you need to know. The other one is called candelas, and that measures stuff to do with light and luminosity, but we don't need to worry about that, as I said. So you need to be able to just list them and list their quantities and stuff like that. But you also need to be able to derive other units from these ones here. So if I just make these slightly smaller, okay, so say we want to derive the units for joules. So we want to derive joules in SI base units. First of all, we find an equation where our answer is in joules. So the equation I always tend to go for is the kinetic energy equation, which is a half mv squared. Often you want to find an equation that already has a lot of stuff in SI base units, or you know the values in SI base units, stuff like that. That'll become more relevant later whenever you are coming on to things like ohms and stuff like that. So we know that this is going to be measured in joules, so I tend to write it out like an equation still. So we don't need to worry about any numerical values. Numerical values don't have units, so the half doesn't need to be included. Mass is measured in kilograms, and velocity is measured in meters per second. So that's all squared. So then you've got kilograms times, and if you square something in a bracket, you've got to square each term. So then it's m squared s to the minus 2. So that means that joules is the equivalent, I'm going to use the equivalent sign, of kg m squared s to the minus 2. Easy as pie. Okay, let's have a go at another one. So say we want to find SI base units for a watt, as in a unit of power. So once again, we choose an equation that has watts as its answer. The one that people tend to try to go for is P equals IV, but then you've got to think volts. You don't know the SI units for volts, so we don't really want to go and start using that. So the equation I would go for is power equals energy over time, especially because we've just worked out energy, so it's super handy. So power is measured in watts, energy is measured in joules, which we just found out was kilogram meter squared s to the minus 2, and then time is measured in seconds, so we're dividing it by time. So that means watts are equivalent to, and whenever we're doing our indices, so seconds to the minus 2, and that's obviously seconds to the minus 1, but whenever they're divided, you take away their indices, so that's minus 2 minus 1 then. So we get kilogram meter squared second to the minus 3. So there we go. That's our SI base unit for a watt. So let's have one more go. So this time we're going to do the SI base units for an ohm, which is a unit of resistance. Excuse me. So for this one, there's a range of different equations we can use. I am going to choose the equation P equals I squared R, because we just found out the SI base unit for P, and current is measured in amps, which is already an SI base unit, so you can see where I'm going with this. So rearrange first to get resistance to be the subject, so that's power over current squared. So that means ohm is equal to, and power was kilogram meter squared second to the -3 all over, and that's amp squared. Once again, we just bring this all up into the one line. So an ohm is equivalent to kilogram A to the -2 m squared s to the -3. It doesn't really matter where you put your A. I tend to put it after the kilograms and before the meters, but it really doesn't matter where you put it, as long as it's in the units. But yeah, that's a few examples then of how to use your SI base units to derive the very base unit for different quantities. Thank you for watching. I hope this helped, and good luck with your questions. Bye.